Okay, yeah. So I've been looking, obviously, at things that cause networks to fail for a number of years. My current day job at Akamai doesn't actually have a lot to do with that because we worry about how to get content around even when networks are failing. But I'm still involved with helping some ISPs, including NetAccess, and I've seen over the years a large number of failures and a lot of patterns in those failures. Also at Akamai, we've been doing some security vulnerability analysis for people, and there are some common themes that we, sort of weak points that we find in the infrastructure. And the main takeaway from this is I think that there are some vendors who are interested in looking at some medium-term things that can be done with deployed hardware that don't cost you more CapEx. And if there are network operators, especially medium-sized ones, who are interested in participating, I think that we could look at some modifications to existing networks that would be helpful. So I'll get into that. So the main question that I have really for a lot of network architects is, do we spend enough energy worrying about security versus scalability and reliability? In other words, who am I peering with? Who am I getting transit from? What routers am I using? What failure modes do they normally have? Versus what if people actually want to cause my network to fail? I think that there's a growing awareness that it's important to think about filtering and protection and things that you can do in the routing infrastructure and the switching infrastructure and your out-of-band infrastructure when you deploy your network, but I still think it's something that we need to be better about as we bring people up internally and as architects running networks that we need to think about in terms of how we can use our existing deployed equipment to make our network better. Most people I know don't have large capital budgets this year. Anyone, raise your hand if you have a capital budget that is more than 25% of what your capital budget was 2 years ago for this year? We have a few hands, How about more than 50% of what it was 2 years ago? Okay, we still have some hands. I'm impressed. So, so why worry? Really, there are two things that I wanted to address. The first is that just by misconfiguration and accident, we've had a lot of outages that have had multi-hour effects on the infrastructure over the last 5-6 years, probably going back a little further, that relate to route redistribution. You can argue back and forth whether you should have the ability to redistribute routes from BGP into your IGP. I know I have, many evenings, but the bottom line is people use it and it's unlikely to be taken away as a capability. But the other piece is if you run a national infrastructure or a global infrastructure and you've got a backbone area which stretches across a large portion of your network and you don't guarantee the physical security of all your machines, all it takes is 5 minutes for any field tech to go and type 2 commands in or reboot it with a flash and basically take down your network and require you to physically touch all your machines, all your core routers to get them back up. One of the questions that I have is, what is the effect of segmenting your backbone area architecture, whether it's EIGRP, ISIS, those are misconfiguration, or because of an attack? And that's one of the things that I think that I'd like to get a better handle on as I work with different networks. The other question is, what can be done to make it so that the next worm, which actually is targeting the infrastructure rather than affecting the infrastructure by accident, can be mitigated. We've seen a lot of effect on the edge, the routers at the edge in smaller networks, in enterprise networks, and even that ripples through to performance, capacity, CPU effect on routers in the core from worms that are not designed to attack the infrastructure. It's just a secondary benefit that they happen to do that in terms of design. But I think as a lot of people have said, what happens if you get a worm which uses force, which once it infects the hosts, wakes up at some point, does trace routes, blasts the routers with forward source address. Let's say you had 1 million machines doing that. How do you protect your routers? How do you go find those machines? That's a good question. Every time that we've had anyone moderately clueful with programming take a router, and I'm not going to pick on any particular vendors, but any of the common core routers, or edge routers, which have 100 meg capacity to the CPU, which is basically most of the infrastructure, and give them a gig of access into a lab of routers, they can wind up finding packets of patterns which are difficult to filter and which will affect the CPU. So one of the recurring themes as people talk about future architectures is separating the control plane, the CPU monitoring and things that go on, from the forwarding of packets. And I think that there may be some things that we can do in-band physically, but to build a little bit of logical out-of-band, and I'll talk about that. And that's another area that I think that routing vendors that I've talked to would be receptive about working together, at least in lab trials with people, to try to build filtering mechanisms, whether it's MPLS or frame, to get things like that going. That's in terms of CPU protection. Again, if you have a large base and a routing guy writing the attack designed to affect routers, I think you could have an attack of biblical proportions, something that would be a multi-day event if it were stopped and started, and would be really hard to figure out what the appropriate filters to put in place would be. In terms of redistribution, again, I don't know of any evidence that anyone's done it on purpose, but it's easy to see how it could be done on purpose. And even in the case of where it's happened by accident, it's had fairly large impact on the given network where it's happened, and when it happens to very large networks, on the ancillary networks, even to people who are just multi-homed in many cases. So the main question I have there again is, what can be done to segment? And if any people have comments, if any people have looked at this, it's something that we're thinking of looking at for a few networks, and hopefully next NANOG or the NANOG after, we might have some data about. Another note that I have is, and I don't really have a useful suggestion for this at this point, I see an increasing trend towards fewer interconnection pops for medium-sized networks, and even international networks as they touch down in the U.S. And I'm not going to worry about people with rocket launchers blowing up buildings necessarily, but less interconnection diversity is probably, it doesn't enhance the infrastructure, the robustness of the infrastructure. So I guess the question is, what can we do to make it economically feasible for there to be more than just 3 or 4 buildings that a lot of people's connectivity go through? Don't have a good answer for that, but that's also something that we're looking at. I think that your helpful partner, the government, has finally gotten off of that and is not likely to continue to try to drive that theme, but it's something that I think as a community we should look at. Another piece that I think network engineers have a lot that they can do to enhance is DNS infrastructure. I actually don't really care that much about whether the routes are reachable on a minute-by-minute basis, but users care a great deal about whether the resolving name servers are reachable on a minute-by-minute basis. And it's also pretty hard to take out to do an attack, or relatively hard to do an attack, which will take out authoritative servers that have TTLs that are in the less than hours range for hours. But in terms of giving people a robust resolving infrastructure, we've been doing a lot of monitoring of DNS, and we see a lot of effects, a lot of impact on a local basis on DNS servers that dial-up users use, DSL users use, that enterprises use, that people run for networks who don't run their own resolving infrastructure. I think that there's a talk this afternoon about some of the Anycast project for, was it FRoot? Right, yeah. So, and I think that people who should look at that architecture and ask whether it could be done internally. How many people run Anycast on or replicated IP address for DNS infrastructure internally in their network today? Anyone? Any people thinking of it?
How many people know what Anycast is?
You know what? How many people run multiple DNS servers with the same IP address that is visible to the public? Right. That's Anycast. So I think it's a useful way for UDP-based things of getting some additional capacity and making you a little bit more resistant, or at least syncing the TAC traffic that you do get to affect only a piece of your network. So that's another relatively minor topic. I'm more concerned with how do we make it so bad guys or incompetence can't quickly devastate your network, your routing infrastructure. Another piece, I've looked at a lot of medium-sized networks in the last 6 months, and a lot of them haven't touched their TACAC servers for 2 or 3 years. They have people who have root access on those TACAC servers that no longer work for the company. The software has vulnerabilities. Granted, there's often access controls on who can get in, but the typical history is that I see, I can name you a number of networks, even some fairly large ones, is we don't trust the IT people to run Unix machines, so we're going to set up some Unix machines because we all have Unix machines at home. Let's just run TACACs on it, that's easy, and then once it's working, you leave it alone. I would just encourage people to look at that. The other thing that I would say is that it also is a good idea that not everyone who has Enable have root on the machines which log what goes on in the infrastructure. I've seen a couple of events that have wound up affecting stability of networks, where people have done misconfigurations, where forensically winds up being hard because there was a misconfiguration and then there's also a period of missing logs. That also, it can happen when if it's the same person, you're just screwed. If it's the same person doing everything and you're one person, that's a problem. But if you have 10 people doing both, you want to have some separate access control there. So that's a relatively minor point. So in terms of just what we talked about, just to summarize, diverse DNS software is one thing that I think is interesting, trying to run different code bases. I know that Nominum has something going in SD in terms of authoritative. I'm not sure what a second good code base next to Bind would be for resolving. I think also devoting some thought to replicating not just the bandwidth, but the CPU processing capacity of the ability to take actual DNS requests is important. In terms of router hardening, I think that it would be interesting to study different ways of getting out-of-band access logically. I think that you can talk about, there may be ways of doing queuing of what can get to the control plane, but I think when you look at all the different things that routers can be running, statically or dynamically building filters about, say, this many BGP packets or this many IGP packets and from this interface and from that interface is a little bit too complicated. Most of the people that I've talked to are not up to trying to build something that complicated. But I think that, and I apologize for not having pretty diagrams, I think that MPLS with separate routing tables and the ability to run virtual networks on top of the same infrastructure, or even frame relay, where you have a single prefix which you number your control devices and your routers in, and then you ensure that that traffic can only come from interfaces that are connected to that virtual network. I think that has some promise. Unknown right now whether that would work, but I think that it'd be interesting to do some lab work on that. In terms of redistribution, the R&D question is really, does segmenting your IGP help? I think it does, but I haven't tried to actually attack any real or lab networks that are one large backbone area versus not. Basically, the question is, if you have 5 locations which you can control and you can run, say, area 0 there, and then you've got 10 other locations in one region which are fairly important but which you don't have physical access to, if you run them in a separate area and you only have 1 or 2 routers that bridge them, and you only do that with summarization, can you actually limit the damage if somehow you get 100,000 routes extra in your IGP in area 1? I suspect the answer is yes. I don't know. It'd be interesting to see, and I know that a couple of major router vendors, I think, have resources and have customers who are interested in answering those questions. So, and then the CPU protection question. And that's pretty much what I had. Just some thoughts and really question of what people do or what people have studied in terms of attacking IGP or limiting damage that can happen when your IGP gets flooded. And second, in terms of limiting or protecting the CPU, the resources of your CPU and your routers. Yes?
Yeah, there's another impending threat that I haven't heard anyone mention. Right now, if all the sales can pick up the phone and call each other, if we start, as some people are thinking of would be the eventual state of things, running the phone network over the IP network, and eventually get rid of the phone network, we won't even have that. So it is important to think in terms of logical or physical out-of-band channels, hopefully not just the phone, in order to recover from disasters.
Maybe Packet Clearinghouse can set up a smoke signal network in the Bay Area.
The smokes will be the smokes of the colo centers melting down.
No, I mean, it's an interesting question. I just stayed away from the whole converged telephony area. And I think that when you can't make your converged routers run well against paranoid attacks, you're pretty stupid to put all your telephone traffic on them. Now, there are some people who are doing that. I don't think it's, but at the same time, you can go, related, which is what happens if someone were going to attack the infrastructure. Again, this is your government in the paranoid sense thing, and you blow up NANOG first, or you give credit problems to the people who have to deal with the infrastructure and make them, worry about other things. There are, even some, there are a lot of different pieces for people to worry about, but so, I mean, I think it's a valid concern, but I think you also have to look at things like, if you're looking at that, you have to look at how do we get beyond a sort of bilateral bunch of engineers knowing each other in terms of some of the debugging that goes on when there's router vendor issues or concerted attacks, and the infrastructure may not be working. In other words, if I can't get to you in your phone book, or AIM doesn't work, or you may find it's not just the telephone. People use the infrastructure that they have, or it's a relatively few people that connect fairly large companies to other companies. And that chain of communication overall, not just how you do it, but the relationships between people may be weak also.
Thank you.
Anyway, so if anyone is interested in looking at this, we're doing some lab work with both the IGP area attack scenarios and some of the, we're not doing the MPLS type thing, but we're looking at frame relay encapsulation with different PVCs and filtering policy to try to do rate limiting of what can get to the CPU, or at least segregation. And if anyone's interested, you can pop me email, avi@akamai.com, avi@friedman.net, avi@netaccess.com. Is there a heckle over there?
Yeah.
Okay.
Gonna go get a microphone to say phone use.
You speak loudly, but we should honor the rules. This isn't IPv6 related, is it? Because you have a time to talk about that.
So what happens when you have IPv6, whose only IGP is RIP2? No, that's a different discussion.
There are people who think that. But
Yes, that's true. How does the end user distinguish an infrastructure attack from an application attack? You talked about DNS, and for the people that I've talked to, they basically say the DNS is down. And we have to carefully explain to them that the DNS is perfectly fine. It's the bits and pieces between themselves and the DNS servers that are the problem. So how do you help people distinguish the fact that it's really the infrastructure that's fallen apart, it's not the service at the other end?
Well, I'm not going to address the how do you get users to go beyond the whole there are many stars in my traceroute as a diagnostic, level of understanding.
You have people that know traceroute?
Yes.
Ooh.
People who call us up and say, there are too many stars in my traceroute, please fix
Okay.
it. But we say, no, stars are pretty, don't worry about that. But no, I mean, but seriously, the comment about DNS, and as I was saying, really into resolving infrastructure is, why not, if you've got control boxes in your POPs, why not distribute resolving DNS so that it really is local to them? So that DNS, I'm going to sidestep the question and say it shouldn't be. It should be that if they can get to your network, they can get resolving DNS capability. And again, I'm not talking about your average core network. I'm talking about people who run dial infrastructure, DSL infrastructure, access infrastructure, where you've got a bunch of keys, coming in, or OCs coming into an area, where you're doing enterprise or end user resolving for the users.
But I don't want you to sidestep the question.
Okay. Well, that's because I have no good answer for the core question, which is...
Okay, thank
Right.
you.
No problem.
There are no answers there. The broad distribution, putting and resolving name server pretty much everywhere,
Yeah.
has its own set of issues
Mm-hmm.
having to do with cache coherency, which, as far as I can tell, very few people are looking into at this point. So, but that's an entirely different set of problems. So, it doesn't look like there's a whole lot of real good answers here, just a lot of interesting questions.
But I guess my selfish bias is that I'm never going to be able to make people not run Microsoft and, run OSs that do, that don't allow buffer overflows and all that. That's just not realistically going to happen. So I look at what can you do to protect your infrastructure so that all the attack traffic can get out to the edge, do its damage. You're going to have some modulating effects in BGP. That's okay. We understand that. That's state of the art. That's what happens today, and the internet basically muddles along. My concern is what happens when they take our tools, which is the CPUs of our routers, that actually have to make the, populate the forwarding tables and remove those. Now, to the end user, that may be just as devastating as something which takes out their LAN, but I don't really care about that because I don't have to fix every end user's LAN. I just have to, the networks that I am dealing with, we just have to make sure that the packets flow through our network well. So that's why I'm looking not at the application layer primarily. Other heckles, comments? I think we need to move on.
All right. Thank you, Avi.